It's called Nintendo. This is not Nintendo. No, this is test review for my honors guys, and I need to change that, I guess. The camera's in the way. Okay. Hey, Charlie. If I'm really quiet, tell me, because I kind of set this up without doing anything. Normally, I like test everything. Yes, Sean, honors algebra 2. Hi, Chad. So while people are coming in, um, all of this stuff is like notes condensed. So I want to go over that first. Just like a really quick overview of all this transformation stuff. Um, Obviously, it starts with function composition, but then it goes into everything else. This is all found in your OneNote. Okay, so if you can't see this or I go past it, um, all of this is in all. You can access all of this. Okay, so I put this in our class notebook. Um, After I do that, I want to go over the rest of the practice test. I was gonna generate a new one, but then I left my laptop at school yesterday, so I can't do that. So um, I'll at least go over some of these notes, kind of explain it maybe in a slightly better way. Most of it's going to be the same, but I want to try and explain a couple of things differently, and then I'll do a couple of examples, and then we'll go to the practice test. So I'll still make it worth your while, even if you finish the practice test, even if you got all the right answers. Um, this is all in OneNote, but this is all going to be really important later on, because the better we're able to do this stuff, the better we're going to be able to do stuff later on. Okay, so trig actually ends up using this stuff. There's a couple of things in calculus that use it a lot. It's generally just really helpful to be able to do. Okay, so this isn't for nothing. It may seem like it, and sometimes it seems like it teaching it, but this is all like analytic stuff that's really helpful to have. This is all background stuff. Okay, so we'll start in the next like 3 minutes or so. Um, in the meantime, how was your snow days? I hope they were good. I did nothing. I was gonna go out and drive in it, um, but then I would have had to have taken it out of my driveway, and I wouldn't have been able to get it back up. So I just kind of left it in the driveway. It was like a sheet of ice, and where my car was parked, there was no ice. I went and drove the next day though. It was a lot easier. I made $500 from shoveling. That's good. There were a couple kids in my subdivision that were trying to like sell driveway shovels and not sell driveway shovel. They were trying to shovel driveways. Um, they came to me and I just said no Can we get one more review day? No, we're good with review days. We've reviewed for a couple of days now. I think we're fine. You've had plenty of things. You can go back into the homework. I think we'll be good. And that's what this is for. And you get to watch it over and over again. Will there be a retake? Alex, that is entirely up to you. It's not that I didn't want to support them. It's just they were trying to shovel driveways like in the middle of a blizzard. I'm not paying for 2 driveway shovels. And it takes like 10 minutes to do it. It's not that bad. Or you just get lazy and throw out a bunch of salt. Yep. I hate coids. All right. It's 7:35, so I'll go ahead and start this stuff. As you have questions, as usual, put them either email them to me or put them in this chat. I'll be keeping an eye on it. Um, I don't know about the orphans. I don't know. I don't know. If an orphan came to me trying to shovel a driveway, I wouldn't have known the difference. I just didn't want to pay for someone to shovel my driveway. Okay, so first thing we're gonna do on this function composition, I just want to do a really quick review of some of this stuff, because this stuff is especially really helpful. Function composition. So every function has an input and an output, right? So if we have some function f of x, say we don't know what it is, x is our input into that function. And when you input that value, this entire thing gives you an output. Okay, so let's say f of x, say we did know what f of x is. F of x is x squared plus 3x. Okay, x tells us what what we're inputting into the algorithm, right? The algorithm is you square it and then you add 3 times that input. Okay, so that's what we're doing. So in this case, I gave you and I'm going to try and zoom in here. All right, so in this case, I'm giving you a function, 3x squared plus 2x plus 1, right? That's 3 times an input squared plus 2 times the input plus 1, right? So there's 2 different things. You square the input, you multiply it by 3, then you add 2 times the input to that, and then you add 1 to it, right? So that's just an algorithm. X is just the input, and then g of x is 7 times an input plus 1. Okay, and we're going to compose those. So we're going to take... First, we're going to find f of g of x, right, which is this guy right here. Okay, and then we're going to find g of f of x, which is this second one. Okay, so f of g of x just means that we're taking all of g of x and we're going to shove it into the x that we originally saw in f of x. Okay, so new input. And when we do that, we're just taking all of this and we're shoving it into our original x's. Okay, so we get 3 times the quantity 7x plus 1 squared plus 2 times 7x plus 1 plus 1. And then what you would do with this is you would FOIL this out, you'd multiply all that by 3, you'd distribute this 2, you'd add all that 1, and you just simplify, and then that would be your answer. Okay, so really not super difficult, but there are some tricky pieces in there, right? Got to keep in mind to FOIL anything, you got to combine like terms. A couple places you can go wrong. Okay, g of f of x is the exact same thing. In this case, it's a lot easier, right? So now we're taking f of x as our input into g of x. So everywhere we see an x in g of x, we're plugging that in. Distribute the 7, add the 1, and you end up getting 21x squared plus 14x plus 8. Okay, that should be simple enough. We've been doing that pretty much all year, and you definitely hit it last year in Algebra 1, or at least you should have. Okay, general overview, you need this in order to do the next stuff, which is why we covered that first. Okay, then we got into the parent functions, right? And there's going to be 6 parent functions. I'm going to zoom out for a second. Just so we can see all of it. We have 6 parent functions, right? Each of them have a name. You don't need to know the names of them, but you do need to know the behaviors of them. Okay, so f of x equals x, that's the linear function, right? That's just your standard line. That's the most basic line you can get with a slope. Okay, right? You input some number and you just get that number back out, right? So your inputs are your outputs. Then we have f of x equals x squared. That is the function we dealt with a lot last semester, right? So we know how to find the zeros of those. We know how to find the vertex, all that good stuff. That's just another parent function, right? And this parent function is a parabola. You take an input, you square it, and then you plot that point, right? So up here, right, that's 2. And then this should go up 4, 1. Yep. So this should be 2, 4. And it's symmetric on both sides. Okay, so we should know what that looks like. Then is x cubed. Same thing, you take your input, you multiply it by itself 3 times, and you get an output. And then your general graph is going to look like this over here. Okay, same thing for square root of x. You're just inputting some number, you're taking the square root of it, and you're getting a number out. Okay, things to notice on this, it can't go over here, right? You can't input negatives into a square root because that'll get you complex numbers, which you can't graph on a real number line. Okay, then 1 over x, we talked about this a little bit. When you have the reciprocal function, right, this in yellow, every number that gets bigger, right, you're actually making the output really, really small. That's what's happening over there. Okay, and as you put numbers really, really close to 0, that's actually making the output really, really big, which is why it's going up to the left. Okay, this function, right, this entire thing is both of those lines. In order to graph 1 over x, you need both of those yellow pieces. Okay, I see a lot of mistakes on homework and in my older guys that just forget like the second half of it, and then it's not right. Okay, it is both of those. One side is positive inputs, and the other side is negative inputs. Okay, then we have absolute value of x. We spent a little bit of time on this last semester, right? This just gives you the distance from 0. Okay, so any negative numbers just become positive, and that's pretty much it. You just take those and you plot them, and you get this shape. Okay, so these 6 shapes, right, we need to know. We need to be able to recognize them really, really quickly. And then after that, you need to be able to apply transformations to them. Okay, so step 1 is recognize them, which seems like we're doing pretty well with. And then the second part is to apply transformations. Okay, and then we have some general rules for translations, reflections, and dilations, right? And the summation, the sum of those things is this entire box. Okay, how many things do we need to plot? I mean, I would at least have like 2 or 3 points. For something like square root of x, where it's pretty simple, you probably only need 1 or 2. For something like a cubic, where it could be a lot of different things, I would suggest plotting 3. Okay, for a line, that should be pretty simple. For a quadratic, that should be pretty simple. Okay, but once we get into like 1 over x or x cubed, or absolute value of x or x squared, it doesn't take long to just plug numbers into a function and get an output. Okay, you're gonna have your calculators. You can even check with your graphing calculator. Really, I just want us to be able to recognize parent functions and then be able to move them around and see what that happens in terms of the function. Okay, so those are our 6. And then these are our rules. And I want to give us maybe an example here. Let's say we have this function, and we're going to have, let's do the absolute value of 1/3 x minus 5, and then minus 2. Do we need to label each point, or will you just look in the xy table? If you have an xy table, that's fine. If you don't, it's helpful. Okay, so in this example, right, if I just gave you this function and I said graph it, we need to be able to kind of think about what's happening, right? So before I even make a graph here, which I'll do, and we can kind of fill in. We should describe the translations and transformations and reflections and all that stuff. And actually, I want to throw a negative in here just for fun. Okay. So the first thing we need to be able to recognize is like the actual like function that we're editing almost, right? And the actual function, this f of x, that's going to be the absolute value of x. Okay, and then we're just kind of describing what happens. Okay, so this negative on the outside, that means we're flipping it upside down. This is a reflection about the x-axis. Okay, so that means it's going to be upside down. So we're going to have an absolute value function. It's going to be upside down, so it's going to look something like this. Okay, and then here is where I kind of screwed up the first time I explained this, and then we kind of corrected it during class. When you have parentheses in here, right, think about this thing as your original input. Okay, so you're still shifting right 5, which is what this means. And we're still going to shift down 2, which is what this means. But then we have this other thing in here. Let's do orange, I guess. We still have that thing, which does something. Okay, and that's going to be, it's inside our function, right? It's inside the absolute value bars. It's going to be less than 1, so it's going to be a horizontal stretch. You don't necessarily need to call it a horizontal stretch. You do need to know what it does, though. Okay, so I know a horizontal stretch, right? If you were going to take both ends of the graph and kind of stretch it out, that would make the graph less steep. Okay, so we have the absolute value function. It's going to shift right 5. Okay, and it's going to shift down 2. Right, so that's going to be our vertex point, that point right there. And I'm going to, yeah, okay, we can still see that. Then, right, we need to be able to plug in a couple points. Okay, we know it's going to be wider, and the slope should be 1/3, and it should be upside down. But let's just plug in a couple points just so we know. Right, so we have an xy table here. Let's plug in one number to the left and one number to the right. Okay, so if we plug in like 4, we get 1/3, I guess negative 1/3. Whoops, nope. Negative absolute value of 1/3, 4 minus 5, and then minus 2. Okay, so negative 1, negative 1/3, that gives out positive 1/3, which then becomes negative again, and then minus 2. So that's going to give us like what? So let's do some math here. Negative 1/3 minus 2, so negative 1/3 minus 6/3, which is negative 7/3, which is just over 2. It's like a third over 2, right? So it's going to be about there. Right, so 4, negative 7/3, that'd be the point that we plot. And we should get the same thing over here. So this would be 6, negative 7/3 as well. Okay, and that's kind of what I would expect you to do. Okay, you could do the reverse. And really it should, 1, 2, 3. It should be like this point right here, but that's fine. I just drew it poorly. All right, so if the slope is negative 1/3, 1, 2, 3. Looks more like that. So that'd be your answer. Okay, where you show the points that you get and then the actual graph. This is all part of your answer, right? You telling me what's going to happen before you actually do it. Ideally, you know that, and you can use the vocabulary that we've been using in order to describe that. Okay, so I hope that makes sense. So that's just a quick example. Okay, I want to go to this. Okay, we did the first two in class. I also have that in OneNote. Okay, so you can look at those kind of on your own. I want to do a couple here. Where did you get the -1? Let me go back. Where did I get the -1? Don't know what you're talking about. -1 and what? No, that's negative absolute value, right? This thing right here, that's negative absolute value of -1/3. Those are like those absolute value bars. Okay, I hope that cleared it up. Okay, so let's do a couple of these. Right, this is your practice test. So your test is going to look exactly like this. 9 questions, couple different types of directions. We'll go through those though. Let's start with number 3. All right. So these directions say to just give an equation of the graph that's shown. Okay, so there's a couple of things we got to do. First thing, identify the parent function. Okay, we should know that that looks like the square root. So our parent function is square root of x. Okay, that's easy enough. It is not going the right direction, so there is a reflection. Okay, and because it's going right, originally it would go this way. So this is going to be a reflection about the y-axis. It's going to be shifted right 1. And it looks steeper. Okay, so we'll just kind of put that there, and we'll deal with that here in a second. The first thing you should do in all of this is get an equation with these 3 things in mind, and then we can figure out the rest after. Okay, so if we just use those, our g of x, our new function, would be the square root of x minus 1, and then it doesn't go up or down. So that's our general equation. Okay, in order to deal with this steeper part, we're going to put some kind of constant in there. Oh, wait, we need to do with the reflection. Okay, so we would do, it's easy enough to do. Okay, so let me start over. Okay, so we still have the square root of x minus 1. Okay, but because it's a reflection, we just gotta stick a negative inside, right? It's a reflection about the y-axis, so the negative is inside the input. Okay, so that's our general equation. I messed up on that. I probably also spelled steeper wrong, but that's okay. In order to deal with this steeper part, right? In order to deal with that dilation, we're gonna just put a constant here, and we're gonna try and find that constant when we plug in some point. Okay. So what we do is we find a point on one of these kind of crossbars, one of these lattice points. Okay. This looks like it works. So 0, 2 is a point that works on this. Okay, so if we plug in 0 into all this, we should get 2 out. right? And then all we would do is we would solve for c. Okay, so 1 is going to be underneath the square root. Square root of 1 is just 1. So all this boils down to 2 is equal to our constant, right? So our function then would be g of x is equal to 2 times the square root of negative x minus 1. You could also put that inside. It could be a square root of negative 4 times x minus 1, but I think this way is a little bit easier. Just makes it a little bit simpler, okay? That's how you do with number 3. And you kind of do the same for all the others, all right? This seems like it takes long when I'm explaining it, but it's not actually that bad, right? So for number 4, if we just go about this, right, we're going to be dealing with x squared, right? It's clearly upside down. It's shifted up to, and it doesn't look wider or narrower, but we'll kind of leave that to check. Okay, our general equation then would be g of x is equal to negative x squared and then up to, so plus 2. Right, so that'd be our general equation. So in order to solve this, we would do g of x is equal to negative cx squared plus 2. We'd find a point that works, and we'd plug it in and solve for c. Okay, so in this case, let's do 2, negative 2. So that's a point that works. So when we plug in 2, we should get negative 2. Right, so negative 2 should be equal to negative constant times 2 squared plus 2. And then we would just solve for the constant, and then we have our equation. Right, so negative 2 is equal to negative 4c plus 2. Subtract 2 from both sides, we get negative 4 is equal to negative 4c. c is equal to 1. So our general equation was actually the right one. Okay, so g of x is equal to negative x squared plus 2. Okay, so before I scroll off of this, I'll give people a chance to look at it if I explained it too fast, and then as you have questions, just post them. All right, I'm taking that as a no. I'm taking that as everything seems good. So I'm going to scroll down, and we're going to do these 2 problems. All right, and then we'll do the last couple. Okay, so identify the parent function, then explain the transformations, sketch the graph of each function. Okay, so hi, Jack. So what we're going to do, we're kind of going to do the same thing in reverse order up top. All right, so we have a function, and we just have to explain each of these pieces, right? So there's the 1/3, and then there is the negative, and that's really all we have to explain. Okay, so the 1/3, that's on the outside, so that is a vertical something, right? So 1/3, this is a vertical shrink, right? So it's going to be wider. And then the negative just means it's upside down. So the negative is on the outside, so that means upside down. And then our parent function, that's just absolute value of x. Okay, so we just take those and we graph them. It doesn't shift up or down or left and right. So it starts pretty simple. Starts at 0, 0. And then we could plug in a point if you wanted to. So let's plug in like 3. Right, so if we do negative 1/3 times the absolute value of 3, that's just going to give us negative 1. Okay, so 3, negative 1 is a point, which means negative 3, negative 1 is also a point. And that gives you 2 points that you can kind of draw lines to. I'll make it look good. That looks bad. Let's just draw it. Do we have to write vertical and horizontal for the shrinks and stretches? No, you just need, well, I mean, it's helpful. It's helpful to use the vocabulary that we've been using. If that confuses you, though, you don't have to. Right? If you just wanted to say it's wider, that's fine. Upside down, that's fine. That's what I've been using. I know vertical and horizontal shrinks and stretches, you can get mixed up. Really, I just want you to be able to identify if they're going to be wider, narrower, and why. So you don't have to use like a vertical stretch or shrink. But it's nice too. All right, number 6. Number 6 is a little bit different. I'm going to rewrite this so it makes more sense. So this is really 3 times 1 divided by x minus 3. Okay, that can kind of help you identify what's actually happening. Okay, so this 3 on the outside, is a vertical stretch, right? We're multiplying by this thing by some constant greater than 3 or greater than 1. So this is going to be narrower, right? And again, if you just want to write narrower, that's fine. And then maybe point to that number. And then nothing else is different except it is to the right 3. That's it. Okay. Now 1 over x is a little bit harder to draw, right? If it's just right 3, that means we don't actually hit this dotted line, and we don't actually hit this horizontal line. Okay, so if it were shifted up, we would take this horizontal dotted line and we would shift it up. Okay, but nothing happened about it. Okay, and then again, we can just plug in points. Okay, so if we plug in 4, right, we get 3 over 4 minus 3, which is 3 over 1, which is just 3, right? So that would be right here. Okay, you're probably going to need a couple more points from this. The good thing is you only have to really do one side because it's symmetric. Okay, so we could do, right, we know it's going to be steeper coming up here. So let's see, let's do like 5. All right, so 3 divided by 5 minus 3, that's 3 halves. So that's like 1.5, so that is right there. Okay, and it's going to look like the same thing on the left-hand side, right? So if you go over 1, instead of going up 3, we should go down 3. And then instead of going over 2 and up 1.5, we should go down 1.5. Right, we know it gets really, really steep, and then really, really not steep. Okay, so again, I want to give people a couple seconds to look at that, just make sure it makes sense, and then I'll go to the next couple. So last two, and then something so these are harder too. So this is a little bit more challenging. So this should kind of make you think a little bit harder. All right. So number 7, obviously it's the square root of x, but then we need to identify what's happening. Okay, so this plus 2 on the inside, that means we're shifting left 2. This minus 3 on the outside, that means we go down 3. And then this 3, this multiplier, means we're getting steeper, right? So that's a vertical stretch. Yes, vertical stretch. Okay. So if we just drew like a rough sketch, left 2, down 3, that would start right here. And then square root of x is going to kind of look like this. But we know it's going to be steeper in this case because of that 3. Okay. So again, we could just plug in a couple points. Right, so if we plug in -1, right? So we're using these cross points that normally work, right? 1, 1, 4, 2, that's where it would normally be. So if we plugged in 1, or in this case -1, 3 times -1 plus 2 minus 3, -1 plus 2, that's 1, 3 times 1, so that'll give us 0. And then we could plug in one more just for safe bet. That's not where that goes. Let's plug in 2. Right, so 3, 2 plus 2 minus 3. So 3 times 2, that's 6. 6 minus 3 is 3. Okay, so it would be right here. All right, so our graph, it's going to look a lot steeper. It's going to kind of go like this. I don't know what that means. If the plot dx, I'll just keep going, and if you find a way to ask your question, I'll answer it. This next one, again, we're dealing with x cubed. If the plotted point is 3, 3, then how isn't the point on the dotted line? The blue, sorry, the blue. The red would be like the original. So I'm gonna have to explain some things. Sorry, so this is the square root of x plus 2 minus 3. So that's without like that multiplier, and then the blue is the actual function, right? So, sorry, that's my bad. So that's what we're looking for. If the plotted point is 3, 3, then how isn't the plot on the dot, or the point on the dotted line? So I guess you're talking about number 6. If the point is 3, 3. No. So, okay, I see what you're saying. We plugged in 4 into our function. That doesn't look good. We plugged in 4 into our function, and when we plug in 4, we get 3. Right, so the point we would get is 4, 3, not 3, 3. Right, and that's this point right here. Three, 3 wouldn't be. You're right. And it's good that you're kind of questioning that. But we get 4, 3, not 3, 3. I'll come back to that if I need to. Okay, but for number 8, we should know the shape, right? We're dealing with x cubed. Okay, so this is a good example of where I screwed up explaining this. Okay, we're just going to deal with this, right? And that'll give us the general shape. So that minus 3 inside means we go right 3. Okay, so I'm gonna sketch like the general. So I want to sketch x minus 3 cubed first, and then we'll talk about what happens on the inside. Okay, so if we just shifted to right 3, we would go it would look something like this. I didn't draw this very well. That's what it would look like. Okay, so that's the parent function just shifted right 3 units. What we need to do is we need to have that 1/2 in there. Okay, so we'll do that in red. Okay, so if we just plug in a couple points, let's plug in 4 and we can try 5. Okay, so if we plug in 4, we get 1/2 4 minus 3 cubed. Right, so that is, whoops, that cube should be on the outside of everything. Right, so it should look like this. So 4 minus 3, that's just 1. We have 1/2. 1/2 cubed is going to be 1/8. Okay, so that's really, really tiny. You can think of that as 1/8. And then 5. Okay, 5 minus 3 is 2. 2 times 1/2, that's just 1. 1 cubed is just going to be 1. Right, and if we go on the other side, it's going to be negative 1/8 and negative 1. Then we can plug in 6 and just see what happens. So we're still going to go through the same point. And this should give us something a little bit more interesting. 6 minus 3, that's 3. 3/2 cubed is going to give us 27/8, which is like just over 3. Right, so our graph is going to be a little bit wider. All right, what I would do if I were you on this question on the test, or a question like this on the test, I'd plot a couple points, right? So we'd have the point 4, comma 1/8, right? That'd be a point. We'd have 5, 1, and then you could do 6, comma negative 27/8 if you wanted to. And then it's useful to know that this is going to be symmetric, so whatever happens coming over here, that's going to be the same thing as going to the left. It's just going to be upside down. Okay, so again, I want to give people a second to look at this, make sure they understand it, and then I'll go on to the last one. For the test, are the questions going to be very similar, like the parent functions and things with just new numbers, or will you switch up the questions completely? Yes. It's going to be, we're going to be using the same parent functions. I'm not going to like give you a brand new parent function. All these questions are fair game. I could implant different parent functions into any of these and I would still expect you to be able to do it. That's kind of the goal. Okay, so, number 6 could be a quadratic. Number 4 could be a reciprocal function. Number 3 could be absolute value. I could give you a line. I'm going to steer away from doing that because that makes it way too easy. But yeah, all the rules are what I'm testing. Okay, and the parent functions are just like general shapes. I'm not going to give you like sine of x and ask you to graph that. Not trying to trick you, just trying to test you. Have you made the test yet? No, because I forgot my laptop at school yesterday. So I'm going to do that tomorrow morning. That won't take long to do, though. It's really printing that takes the longest. Mr. Bame, how much partial credit do we get if we only get part of it down? Hi, Max. How are you? That's a good question, though. Uh, Basically, what's going to happen is that each one of these translations or transformations or dilations is going to be worth about a point. Okay, so on a question like number 8, right? We have to be able to shift right 3. We have to be able to make it wider, and then we have to know what this is. So while this is probably isn't a 3-point question because you still have to graph it, this is probably more like a 5 or 6-point question because you have to graph it. Every like little small detail is going to be worth 1 point. Okay, so 3 points just for understanding what's like understanding all of this and what it means. I'll make that look better. Understanding the part in blue, that's a point. Understanding the part I circled in red, that's a point. And understanding that it's gonna be wider, that's a point. So just writing all that stuff down without even graphing it, that's worth at least half credit. Okay, then graphing it is worth the other half. Question like number 7, you know, left 2, down 3, and then steeper. That's 3 points right there. And then the graph itself is worth 3 points. I'm glad someone asked that because that made me have to rethink it again. And I'm so glad it's someone not actually in this class. It's very helpful. I'm glad my students are on it. Okay, last problem, and this is like something we already did. Actually, this is almost exactly the same as what we did before. I'm just gonna draw this out. I'm gonna let you guys finish it. Okay, we need 2 things here. We need f of g of x, and we need g of f of x. Okay, f of g of x is going to be f of 2x plus 8, which is going to be 3 times 2x plus 8 squared, plus 2 times 2x plus 8, minus 1. I'm going to let you guys FOIL that out, combine like terms, and simplify. Again, this is probably worth half the credit. Simplifying, combining like terms, all that stuff is worth the other half. Right, Chad. I know you were about to ask. Sucks that someone beat you to it. So that's f of g of x. Okay, g of f of x should be easier. Right, that's going to be 2 times 3x squared plus 2x minus 1, and then plus 8. Again, I'm going to leave that to you guys to distribute and combine like terms and all that good stuff. Right, but getting that is worth about half credit. The rest is the other half. Okay, that's it. I don't think this should take the entire time. I'll give people the entire time to take this, but I don't really think that this should be that difficult, especially with calculators. You've got a lot of help. All right. But that's it for the test, and that's it for me going over it. So I'll pause for a minute or two and make sure people don't have questions. I'll scroll up to maybe a harder section, like these two. If I don't hear any questions in the next 3 minutes, so let's say by 8:20, we'll call it. But if people keep having questions, I'll go as long as it takes. All right. So I'll mute myself for a second, take a look over this stuff. Again, this is in OneNote, so like you can scroll up and down on your own. I'll kind of do a slow scroll. But I'll mute myself and give pause to anyone with questions. Don't just sleep on this. Go do a problem or two. Go find problems from the homework that you did wrong and redo them. Or from the overview. You have problems. Go do a couple. Just watching me doesn't actually help you study. It helps you remember stuff, but it doesn't help you study. Mr. Bame, if I get 100 on the test, will you 1v1 me and Smash Ultimate on Switch? Uh, sure. Yeah, I can do that. It depends on who's Switch though, because I haven't played Smash Ultimate in a minute, so I don't have like I don't think I unlocked everyone. But yeah, I will. If you get 100, sure. I'll bring it in one day, and during activity period we can do it. I think I'm gonna wing it completely. I know I've heard how this is done in college. Go to practice really now. Yeah. Max, the two classes I'm in are very interesting right now. I'll tell you more about that later. Coding theory is something. And yeah, that's exactly how they do it in college. No one ever prepares. They just kind of come in and ace it. Chad, I'm not gonna take that bet. Um, but if you get 100, I'd be very, very happy. Okay, it's 8:20. We've done all these problems. We've practiced these in class. You've had homeworks over them. I've graded them. If you have questions, come in tomorrow morning. Give me a minute to like actually make and print the test. So probably like 7:45, but I'll be there. Um, and then you guys have all this stuff in OneNote that you can practice off of. Not with that attitude, Justin. You can do it. Will I post this? Uh, yeah, I wouldn't exit out of it though. Uh, so if you're gonna like rewatch it, I would just pause it and then keep this window open. Don't like exit out of it because I think it takes it a minute to like actually upload. So just like stay on this link. Bye, Patrick. But yeah, it should be up. It just sometimes it takes a minute to like actually fully upload. Um, and as long as you stay like on the actual stream, it'll be fine. All right, I'm gonna call it. I will see you guys tomorrow. If you have questions, email me. Come in tomorrow morning. I'll take a couple questions at the very beginning of class, but I think we're okay on this stuff. All right, I will see you guys tomorrow.